Welcome everyone, welcome to my channel Chempedia. Now in this particular video I will discuss you about the different reaction of alkanes, that is part 1. Okay. Now in the previous class we have already known about the alkane, alkene and alkyne. Okay. Now in this particular video I will make sure that I will discuss about the only alkane. Okay. Now I will start with the different reaction. Now there are mainly three types of reaction which can alkane undergo. The first one is substitution reaction. Substitution reactions. And the second one is elimination reaction. Elimination reaction. Now I will discuss you about these two types. Okay, and in the later videos I will discuss about more it. Okay, now let's start about substitution reaction. Substitution reaction. Okay, let's now substitution reaction are mainly of three types. Okay, the first one is SN1 reaction. Okay, now what about SN1? Let's see. SN1 means substitution nucleophilic with respect to first order. That means substitution nucleophilic substitution first order reaction. Okay, now let us see an example, that is Rx. Okay, where R is mainly an alkyl group. Okay, R is mainly an alkyl group. Now in case of if we react with this a polar solvent or polar protic solvent, suppose H2O, then it will undergo ROH form. Now let's see the mechanism of this reaction. Okay, let's see the mechanism of this reaction. Now what about this Rx? Okay, X is a leaving group. Now in this case the first step is the redeeming step. Okay, in the first step the bond breaks here, that is the alkyl halide bond here breaks. Okay, and the carbocation is generated. Okay, it is the redeeming step. This is the slow step of the reaction, but it is the rate determining step of the reaction. Now it is the first step. Okay, now in the second step the R plus, that is the carbocation which forms, undergoes reaction with nucleophile, that is H2O. It will form ROH. Okay, it will form ROH, and this mechanism is called SN1 mechanism. Now why is called it is SN1 mechanism? Because the rate here is rate equal to rate constant Rx. That is, it follows first order kinetics. It follows first order kinetics. Hence it is called first order reaction. Okay, now suppose see an example. Okay, see an example. I am giving an example of tertiary butyl bromide. Tertiary butyl bromide. Okay, it is the main substrate of this reaction. Okay, now I will undergo reaction with H2O. Okay, H2O. Now please remember that the solvent must be polar protic. Okay, the solvent here must be polar protic, because the solvent must be polar protic solvent with high dielectric constant. With high dielectric electric constant. Okay, now in case of tertiary butyl bromide, if we undergo reaction with H2O, it will form CH3 whole 3 COH. It will form tertiary butyl alcohol. Okay, it will form tertiary butyl alcohol. Now let's see the mechanism of this reaction. Okay, I am telling you about the mechanism of this reaction. Now let's see the mechanism. Now the first step is this, the red determining step. As previously I have seen this, that whenever the alkyl halide bond is broken, the carbocation is generated. And this step is the red determining step of this reaction. In the same case, when tertiary butyl bromide, the CBr bond here breaks, and it is the slow step of this reaction. It is the slow step of this reaction, and it form tertiary butyl carbocation. It is called tertiary butyl carbocation. Now in this case, tertiary butyl carbocation, remember the one thing, that the carbocation must be very stable. Okay, must be very stable, but without the stability of the carbocation, it cannot undergo the SN1 reaction. Is the main criteria. The carbocation must be very stable. Okay, the carbocation must be very stable. Now in the second step, the carbocation C plus, we undergo reaction with H2O to form CH3 whole 3 COH, and that is the mechanism of this SN1 reaction. Look at this. I have already seen that there is alkyl halide bond is broken. Okay, now here I have taken Br, but why not I have taken F? Like, okay, yeah, you may have questioned that I have taken CH3 whole 3 C Br, but not F. Not F. Why? Because I can easily take CH3 whole 3 CF, but I cannot take it, because here the main point is the leaving group capacity, leaving group ability. Okay, leaving group ability. Now if we see that the atomic number of fluorine is 9. Okay, atomic number of fluorine is 9, and the electronic configuration is 1s2 2s2 2p5. Okay, now since fluorine is most electronegative element among these, fluorine is the most electronegative element. Okay, since fluorine is the most electronegative element, hence it cannot be a good leaving group. Since it cannot be a good leaving group. Okay, so can't be a good group, since the CF bond is much more stable than CBr bond. Remember this, understand that CF bond is much more stable than CBr bond. That's why I cannot take CF as the SN1 substituent, because the CF bond energy is more higher than the CBr bond. Okay, now hence I will take Br. That's why the leaving group capacity, decreases in the order F greater than Cl greater than Vr greater than I. That's the reason why I choose Br, not F. Okay, remember this point. That now we can see that in this type of reaction SN1, there are main 3 points are there. Okay, the first one is the carbocation stability. And the second one is the solvent effect. Remember one thing here, the solvent must be polar protic. Okay, solvent must be polar protic with high dielectric constant. And the third one is living ability. Living ability. It is these are the most three important points in case of SN1 reaction. Now, there may be a question in SN1 reaction that, and please remember this, that CH3Br undergoes SN1 reaction much SN1 reaction much slower than CH3 whole 3 CBr. Why? That is this type of question mainly asked in 11 or 12 CBSE medium. This is the very good question. Okay, remember this, because let's see, the answer is this, that the carbocation stability. The main hint is the carbocation stability. Carbocation stability. Now, if we undergo the SN1 reaction, that is CH3Br, the first step, the CBr bond is broken and it will form CH3 positive. It is the methyl carbocation. This is the 1 degree carbocation. Okay, it is the 1 degree carbocation. It is the very lower stability. It has very low stability. It's very low stability. But if we choose CH3 whole 3 CBr, the CABr bonds will break and it will form CH3 whole 3 C positive. It is the tertiary carbocation of 3 degree carbocation. It is at a high stability. Okay, high stability. Now, hence the carbocation stability, varies in the order 1 degree greater than 2 degree greater than 3 degree. Hence, we cannot choose CH3Br, but we can choose CH3 whole 3 CBr. Okay, this is the main question. And the second thing is the solvent. Let's say this question number 2, that why benzene is not used in SN1 reaction. Now, why benzene is not used in SN1 reaction? Okay, previously I have already told that benzene is a non-polar solvent, non-polar and aprotic solvent with low dielectric constant. Low dielectric constant. Now, what about the polarity? Here comes the polar. Okay, polar means, you already know about dipole moment. Yes, dipole moment means mu. It always indicated by mu equal to E into D. Now, what about E? E is the charge. E is the charge of the ions, and D is the distance between two ions. Distance between two ions. Okay, that is the, suppose we have NaCl. Okay, NaCl, that is sodium chloride. Whenever it undergoes dissociation in a salt solution, it will form Na plus and Cl minus ion. It is the main difference is it will act as a Na plus Cl minus this type, that is the distance between the Na plus and Cl minus, it's called D, and the charge difference is called E. Okay, now here comes from polarity. Now since benzene is a non-polar, the formula of benzene is the formula of benzene is this is the main formula of benzene, that is the benzene. Okay, it is C6H6, it is called benzene. It is look at it is the structure. It undergoes, it is non-polars and aprotic solvent. Okay, with low dielectric constant, with low dielectric constant. Now what about dielectric constant? Okay, we know that the dielectric constant means it is termed as epsilon. Okay, epsilon means whenever epsilon by epsilon naught, it is the parameter which has no unit.